For section 6.3, if we take a look at the section title, it is Radicals and Rational Exponents. So it actually does tie together our section 6.1, which was radicals, and then section 6.2, which dealt with exponents. So remember that word rational coming off of the base or the root word ratio, fancy word for a fraction. So we're going to look at having fractional exponents. So we saw within the last section that we can have negative exponents as well. Well, now we're going to take a look at having fractional exponents. So in section 6.1, we limited our work to pretty boring, just square roots. However, there is an idea called an nth root. So you can take any root of any number. Now remember what a square root meant. It meant what number to the second power, or what number squared, equals that number that's underneath. So, same idea, the nth root of a number, you would be looking for a number raised to that nth power, the root matching the exponent, to then be able to simplify. So for that first example, you see the third root of 125. So what we're actually asking ourselves is, what number to the third power, multiplied by itself 3 times, is 125? Well, 5 times 5 times 5 is 130 or 125. So 5 to the third, and notice my exponent matches my root. So when the exponent matches the root, the base number just comes to the outside. For the fourth root of 81, we're thinking to ourselves, what number raised to the fourth power, what number times itself 4 times, would equal 81? It is 3, because 3 times 3 times 3 times 3 is 81. So the fourth root of 3 to the fourth, again, when the exponent matches the root, they undo each other. That just equals 3. For number 3, the fifth root of 32. So again, you're asking yourself, what number to the fifth power, so that the root will match the exponent, equals 32. So what number can we multiply by itself 5 times and get 32? It is 2. And realize, the smaller the number is underneath, then the smaller we would have to have that base be. Due to the fifth root, the root undoes that exponent, just equals 2. So realize the fourth root of 81 was 3. So now our root is even bigger of a smaller number, so it would have to be smaller than this answer that we got here for 3. The bigger the root, the higher the exponent we need underneath. So remember, the root needs to match the exponent for those to cancel. On a graphing calculator, or most scientific calculators, there is, if you will, an X root button. To enter that, so there are scientific calculators online. You can just Google scientific calculator. You will enter the root. So if you were doing that last one, the third root of 125, you would enter 3. That's the root. Press your root button, and then enter the number underneath the 125. Press your equals. Those of you using maybe an iPhone, on your iPhone, there is this root button. However, it is the Y root of X. Your phone is going to want you to go in alphabetical order. So you would, again, if I was doing the third root of 125, which we know equals 5, play around with a calculator with a problem that you know an answer to. So then you are able to decide whether or not you're using the calculator correctly. So, alphabetical order, I would use the X first, so I would enter 125. I would hit my Y root of X button that I need by root, and then press equals. So that would be the order on your calculator. For rational exponents, where would fractional exponents come from? They are actually roots. So a root makes a denominator of a fractional exponent. So notice that the fourth root of 81, this root becomes the denominator of a fractional exponent. So the nth root of a, base stays the same, so a raised to the 1/nth. So again, the root goes to the denominator of a fraction. So that first example, the 8th root, so that root is in the denominator of a fraction, so 214 raised to the 1/8. For number 2, start on the inside, the third root of 42. So my 42 stays the same. It is the third root. So the 3 goes in a denominator. But notice that 5 is still in my exponent. Remember, last section, or power of a power, you multiply. 5 times 1/3 would be 5/3. So that exponent does become the numerator of the fraction. The root is the denominator. You do not need to take this middle step. Now that you see where it actually comes from, you can go straight to that final answer then. So in number 3, my base is my radicand, the number underneath the radical. And again, listen to how I'm reading those. The third root, the 8th root. That's not the 8 square root. No, it is a square root when you don't see a number in there as the root. You are to assume that it is the second root or the square root. Number 3, the 12th root. So that 12 would go in the denominator of a fractional exponent. The 11 would be the numerator of that fractional exponent. So again, the root is the denominator, the exponent is the numerator of that rational exponent. The next set of examples is just going back the opposite way. 14, so 14 would be under my root. The 3 on top, the numerator is my exponent. The 4 in the denominator is my root. So the fourth root of 14 cubed. For number 2, 57 would go underneath my root. Well, what root is it? It's the second root, and it's raised to the first power. But realize the second root, read that another way, a square root, we really don't need the 2 there, nor do we need the exponent of 1. 57 to the 1/2 is the same as saying the square root of 57. It's the only root that I don't need to see a number for. 48 to the 5/8, so underneath that root is 48. The 5 in the numerator is my exponent. The 8 is the root from that denominator, so that would be the 8th root of 48 to the 5th power. So, and notice the directions. It asks me to write the expression in rational exponent form. I should see an exponent. Rational exponent means a fractional exponent. Write the expression in radical form. My final answer better have a radical in it. Doesn't ask me to evaluate, just asks me to rewrite those. Well, if you haven't noticed already from the last section, there is an, if you will, exponent button on your calculator. It is the little caret button. So on the graphing calculator, it is over to that right-hand side above the division sign. Different scientific calculators, they all have one. Where it is might be different. Some other calculators have it clear on the left-hand side, so it's just a matter of locating where the button is on the calculator that you prefer to use. The big thing to keep in mind, if you have fractional exponents and you are using that caret button, that exponent button, you must put your fraction in a set of parentheses. So notice I have these parentheses, must use them. So, if I take a look back, my cube root of 125, that's how we practiced the last one. Well, you might say, well, how am I going to use that with the exponent? Well, make that a rational exponent. That is 125 to the 1/3. It should equal 5. Let's see how we would enter that. On your graphing calculator and a lot of the Texas Instrument calculators, the buttons I would press, I would say 125. I would press my caret button, a set of parentheses, open it, 1 divided by 3, that's what fractions really are, division problems, close the set of parentheses, and then hit either equals or enter, depending upon what kind of calculator you have. If you do not put the set of parentheses, most calculators know the order of operations. They take them literally, they don't know what you mean for it to do. Therefore, what it would think is it would say, okay, I know exponents have to go first. Now again, this is without my parentheses. It would say 125, I'm going to raise to the first, get that answer, and then divide it by 3. Whoa, that's not what I meant. Well, then you have to tell your calculator what you mean. You want that 1/3 in the exponent. You need to tell the calculator that. Those of you using your phone, if you're going to use your phone, most phones have an X to the Y button. Alphabetical order again, I would do 125, hit my X to the Y button, then it wants my Y. I still need to put it in parentheses. So I would do 1 divided by 3, close the parenthesis. Now most phones, you're not going to see that parentheses in there. It's okay, the calculator, the phone knows that you want them there. Now, most of your calculator screens, as soon as you close that set of parentheses, it's going to give you 0.333333. Well, no, my answer is 5. All it did was took 1/3. That's the decimal equivalency. Press equals, and then you will get the correct answer, which is 5. So again, you need to learn whatever calculator you're going to choose to use, which I don't care what it is. Use an example that you know the answer to, and see how it's entered correctly into your calculator. So to simplify 216 to the 2/3, depending upon your calculator, you'd either enter 216, caret, parenthesis, 2 divided by 3, close the parentheses, hit equals. Those of you using your phones, same sort of thing. So for these, for the most part, you are going to do the same thing. So again, I would do 216, caret, 2 divided by 3, close it, hit equals, and you do get 6. Here I would do 225, caret, parenthesis, 3 divided by 2, close it, hit equals, that is 125. 49, caret, parenthesis, 1 divided by 2, close it, using your phone, 49, X to the Y button, parenthesis, 1 divided by 2, parenthesis, then equals, it's going to give you 0.5 in the interim, well that's where the 1/2 is, answer is 7. Now realize where these answers are actually coming from. Yes, I'm perfectly fine with you just using a calculator. The 3rd root of 216, what to the 3rd power is 216? It is 6. 6 squared is 36, which should be my answer there. For number 2, that really is the 2nd root, or the square root of 25, which is 5, cubed. There's your 125. This is the 2nd root, or the square root of 49, which is 7, to the 1st power. So that's where these answers actually are coming from. You can go back and forth between the buttons that you're using, the root button or your exponent button. Doesn't matter to me. If you like one of those buttons versus the other, that's fine. Go with it. I don't care what button you use. We're able to rewrite each one of these in the opposite form. I could rewrite the cube root of 216 as 216 to the 1/3. I could rewrite 343 to the 1/3 as the cube root of 343. So if I like one button versus the other, you absolutely can do that. Right? Let me throw some answers in there. Make sure you are practicing with those. So take a few minutes, pause the video, answer these, make sure you're good on your calculator, then restart the video to get those answers. Again, this is a matter of learning your calculator. Whatever calculator you're going to use is completely fine with me. Just make sure it's your job to know how your calculator works. If you have questions on your individual calculator, please ask. We'll figure it out. Last, then, looking at an application problem, which is going to be the same thing. So we're given the radius of a sphere. Our formula, 3v divided by 4 pi, that quantity to the 1/3, where v is the volume of the sphere. So we want the radius of a kickball, there's r, that has a volume, there's v, of 33,510 cubic inches. So let's use our formula and plug in. So r equals 3v, but v is 33,510 divided by 4 pi raised to the 1/3. My calculator, your calculator, can do all of that all at one time. Here's how I enter it. I'm going to do 3 times 33,510. But I want that whole thing to be divided by the whole thing 4 pi. I need to put that 4 pi in a set of parentheses. If not, my calculator will follow the order of operations and take 3 times 33,510 and divide it only by 4, multiply it by pi. No, you want the whole thing. But that whole thing needs to be raised to the 1/3. A lot of parentheses are needed in there. Overuse parentheses. You can never use too many sets of parentheses. Make sure, hey, calculator, I want 3 times 33,510 all in the numerator. Tell it that. Put it in parentheses. Hey, I need to divide by 4 pi. Make sure you put that in a set of parentheses so your calculator knows to keep that in the denominator. I need all of that raised to the 1/3. Put all of it in a set of parentheses. Since you need the 1/3 to stay in the exponent, make sure that also is in a set of parentheses. Hit equals then, and your calculator is going to give you 19.999. These continue for a while, but notice that it says to the nearest inch. This 9, going to bump my other 9 up to 20 inches for my radius. Do not round along the way. So if you're going to do 3 times 33,510, whole answer, write it down. 4 times pi, whole answer, write it down. All calculators have a pi button. Use it. Do not use 3.14. You're chopping it off way too early. Final answers to be rounded? Not a problem. Do not round intermittent steps. You have a calculator, let it do its job.